Assalamualaikum and good morning. Today we are from group 29. I'm going to present our group project, which is AC power analysis for the electrical principles 2. These are our group members. First, Muhammad Amirul Amin bin Ibrahim, Muhammad Musharraf bin Rustam, BJAL Balasundram, and Muhammad Redwan bin Azmal. For this slide, I am going to explain for the introduction. First of all, we were given the task of selecting a circuit to examine based on the subjects of AC power analysis and three-phase circuits in this case study. Then we were given the task of calculating the computation using theoretical and simulation tools, which is we use the multisim software. The problem we chose for this question is from the problem 11.2, and the circuit we chose is a series circuit with a resistor, an inductor, and a capacitor. This task goal is to be apply the fundamental rules and elements of AC circuits to circuit theory analysis. Instantaneous power is the element that we get by multiply instantaneous voltage and also instantaneous current. All of this comes from the basic formula, which is we call as known as P equal to VI. The simple way to understand instantaneous power is the power that is absorbed by the element at any instant of time. For real, the instantaneous power changes with time is difficult to measure. Therefore, the average power is established to make the calculation easier. In fact, what meter that have been used for measuring power indicates the value to an average power value. In our problem, we were assigned to find out the average power that being supplied and absorbed by each element. Average power formula is transformed by integrating instantaneous power formula, which is P equal to 1 over T integration PT dt. Therefore, the final outcome for average power is P equal to 1 over 2 V cos delta dt. We use this formula in order to solve our problem in the figure 11.35.
Hello, my name is Vijay Unlucky Balasundram. My metric number is DN20021. The next part of the presentation, calculation, will be presented by me. We were instructed to find the average power absorbed by each component in the question we chosen. To calculate the power absorbed by each component, we must apply the average power formula P equal to 1 over 2 Vm in cos theta. To achieve the appropriate answer, we must use the formula for each component, then use the correct value provided or used by the component. That's all from me, and I do turn over the presentation to the next presenter. Thank you very much.
So, for the simulation part, number 1, we calculate the capacitive reactance and inductive reactance because in multism we cannot insert the impedance value negative TO and I50. Second, for calculation parts, we set our circuit in range 50-60 Hz and use the formula, which is XL equal to 2 pi FC and XC equal to 1 over 2 pi FC. For number 3, after calculating all the inductor and capacitor value, we insert if on the software. All the result and calculation can be seen as below. Next, the frequency has given is equal to 60 Hz. So, we use the formula XL equal to 2 pi FC. So the value of X is equal to 50. So we just substitute the all of value that's given in the formula. So we will get 50 equal to 2 pi 60 multiplied by C. So we need to find the C. So we get the C equal to 0.13263 equal to 133 amperage. Next, the formula is XC equal to 1 over 2 pi FC. So we just substitute all the value as given into the formula. So we will get 10 equal to 1 over 2 pi multiplied by 60 minus by 1 over C. So we will get 1200N equal to 1 over C. So we need to find the C, and the value of C is equal to 0.0000265 is equal to 265 microF.
I'm Muhammad Amrul Amin. Today I will present my part is result and finding. For this result finding, we found that a slightly different result theoretical and simulation. For the calculation part, the average power supplied by the source is 240, while the result we gain from the multi software is 233. After making some research and doing some modified, we noticed that if we use a roughly value for the inductor and capacitor. Next, we use a significant value for the theoretical method to find the value that's resulting a slight different from both methods. The power average absorbed by the resistor from our calculation is same as a power supplied by the source, which is 240 watt. The result multi-terminal is also the same, which is 233 watt. The same method was used is using three significant figure to complete all finding, and this led to a slightly different from both method. Okay, now I will show you the simulation circuit. Okay, we are compare the simulation and simulation result and calculation result. Now we can see the power absorbed for voltage source is 240, while simulation we get negative 233 because the current will return back to the power source, and then because why we get the negative 23. For the resistor, we power average for resistor we get 240. For the simulation we get the 233 watt because we use a roughly resistor for the circuit. This mean a little bit different and near the same to this to the calculation value. Now we followed by to inductor and capacitor. We get 0 because the negative mean that the coil is returning the stored energy back to the supply, and then the inductor and capacitor have a 0 value because the current lead or lag by the voltage is 90 degree phase angle, so the power is both stored and returned back to the source. Thus the average power over one full cycle will be 0. That's why for the calculation part, inductor and capacitor power average is 0, and the simulation will the same as a calculation. Now we go through with conclusion. In conclusion, we managed to perform the simulation need for the task. Multisim is used to simulate the circuit we choose. Before we use the multisim to analyze the circuit, we use a manual method in order to meet the question demand, which is the average power supply and absorbed by each element. Based on the figure given, the actual value of some element could not be used in the application. By using SL formula and LC formula, for the right value could be obtained. If the manual question and the result from the simulation were the same or nearly the same, miscalculation and misinformation could be prevented. We also learn how to use the multisim software and perform manual calculation. By integrating and analyzing the value, we were able to discern that instantaneous power refer to the power consumed at a specific point in time. Power equal to voltage and current, where V and I are the instantaneous voltage and current in AC circuit give the instantaneous electric power. The average power is calculated by averaging this power across a whole cycle. Thank you. That's all from me.